So we have this energy model, and now at this point, so what I've done is on the board, I went through before what the way we handle the stuff using these unit functions. It's all described in the CS notes. So basically, I'm able to write down. But what I like about the syntax of using macros to represent compensated demand functions is that then that hides all the messiness, and then the equations of the model themselves are relatively clean. Like, so once I've done the algebra above for doing the demands, then I can see the whole equations. Everything's clean. There's no algebra in the equations at all. So
Yeah,
that's
it's
just it looks like this. So the idea is that keeping this relatively compact. So here we have, if we look at the model, and now I'm just going back to the model, I have the representative agent. He makes money from labor, from energy, resources, and capital. There's, in addition, he gets money from a potential carbon tax and a limit on carbon emissions. So that's the first term, the peak C-lim, that's the climate limit. And then the profit on E says, well, the value of sector Y, the cost of sector Y is the energy cost, the capital cost, and labor cost. That's got to be very equal to the value of output. The energy says the cost of the specific factor, that's PR, plus the variable factor P, plus the carbon tax has to be greater equal to what the price is of energy in the market. Where the market for Y says 100 units are output per unit of Y, and that's got to be equal to the input, the demand for Y into energy plus the demand for the final demand for Y. And likewise for energy supply, it goes into the two places. And this all these things just relate back to the matrix. So all the difficulty here is just get the demand functions right, and then the modeling is very easy to do. Right? So that's the increasingly that's what I work. So here we have and we have this specific factor R, which has 5 units. Everything's in Harvard units. That's the value of their earnings in the benchmark. And finally, we have a constraint that says the climate limit has to be greater equal to the amount of energy that's produced. Once we've done that, we write down the market clearance conditions, zero profit, income balance.
that's those three up there, right?
Yeah.
What you just said. Okay.
So zero
Starting to get the
profit,
hang of this.
zero profit, market clearance, income balance. And the market includes a market for carbon.
Mhm. All those up above are all the markets that are.
Yeah, that's right.
balanced,
Those are all
yeah.
the markets. Supply greater equal to demand for all these guys.
Yep.
I assign then a necessary but not sufficient condition that the model makes sense is we should be able to replicate the benchmark. So I assign everything to its benchmark value. The only thing it's not a unit value is the income level, which I set to be 120. That's the value of their benchmark endowment of 80 units of labor plus 35 units of capital and 5 units of energy resources. And then I say iteration limit 0. I say solve this guy. And then and there's one little thing, I'm not sure why I did this, but I said save point. That says save the solution so I can reload the solution when I do a different solve. That's just a technique that helps you accelerate future solves. And if I'm doing a bunch of solves, it's sometimes helpful to be able to go back and start it at the beginning point. So here I just do a solve.
Wait, so you hold on, I didn't fully comprehend that. So you could store it and then you could run like a counterfactual again?
No, I can say, let's just
Like,
say,
what is the point of doing save point?
then I can say, okay, I want to basically, I find it thing works better if I load the benchmark. So there's where the save point produces model underscore P, which is the point.
Yeah.
And then later I can say load that point.
Okay.
So what I'm doing is I'm going to say load the point. Then that gives me a starting point that's right back at the benchmark, and then I go off and solve the thing.
Okay.
So that's, and then I solve the scenarios. And once I've solved the scenarios, then I do some reporting. And the one thing that's this one tricky business about using these macros, and where does it get used here? Actually, I don't think I need it here. I thought I was using the macros, but I'm not using the macros, so I don't really need this. I could go without this. Where is it RA? I don't think, actually, I don't need this here. So I'm saving all the stuff for this run. And then at the bottom, I run it. So let's see what happens when we run this guy. Oops. So I've screwed something up. Oh, it's W. Okay, that's the reason I need this here, because on dot L. The welfare index is the price index for utility times 120. So this is this normalization. So that's the welfare index. So I need to have on dot L to say that means that when it goes to evaluate the macro does not refer to the dot L's. If I say on dot L, it'll substitute the dot L's. So that gives me my whole solution. And so that guy gives me a set of numbers. And here I'm going from a 0% cutback to an 80% cutback, right? And it tells me what happens to the output, macro output, what happens to energy demand. You can see the energy demand follows exactly what the target is. So my carbon limit is a certain percentage cutback, and here we can see the energy output follows exactly. In other words, the third column and the first column, the label of the scenario is the first column, and the third column tells you the energy because we're hitting the target. And we see the price of energy goes up by a factor of 1,500 fold, right?
Jeez.
So to get to 80, and this is again, this is just the point. I apologize for being a little bit pedantic, but what I'm trying to do is, you said you haven't done energy environment. I'm trying to share with you.
No. This is helpful.
Perception. So we have this. If we locally calibrate CS functions to local perturbations, and then we say let's do a shock reducing by 80, we're way outside the domain. And so in that case, this is a case where tell me what the cost is of putting it at that price. I could put in lots of windmills, right? What's the cost? What's the backstop cost? What's the technologies you have? And we can do that in this model. I'm not going to take the time today, but mainly I want to use this model to show you how to instrument it to get this result. I want to do a pivot table where I look at the demand elasticity, the supply elasticity, and the cutback. And I want to have a pivot table to show me each of those items. Let me compare. I want to do a pivot chart on this to look at how it works. And this is just mainly I wanted to use a model that was kind of interesting in terms of using what we've done, but I want to then focus on the mechanics of how we do this.
So what does the 21 mean? It means output's falling by 21%.
Yeah, I think if you look at the results here, let's look at the code.
That's total output for the entire
So
economy.
Y
Right?
dot L is the macro output, E dot L is energy.
Okay.
And then we're looking at what happens the price of energy versus the price of output, the price of labor versus the price of output, price of capital, the price of the return to the resource. And I look at what is the carbon price as a fraction of the energy price. I'm not sure why I do it divided by 10. I'm not sure, but that's so P carb rises to almost
100% of the price of carbon.
Like all but 2% of the cost is the carbon price, right?
Okay, I see.
So that's
that's the way I see. Okay.
Carbon price is a fraction of delivered price
Of the delivered price.
of the gross price.
So basically, if it's $10, basically $9.80 or something like that is all just the carbon price. Is that right?
Yeah.
I think, okay.
And remember, it's this model, we have a specific factor and we have other inputs. And so as we drive down energy use, we use less and less other inputs. It's just the specific factor.
Mhm.
At some point that essentially goes, the price essentially goes.
And so what's happening with the price of labor and capital? They're just falling. That's relative to what?
This is labor and capital. That's the value of labor and capital relative to macro output.
Okay, relative to output. Okay.
Relative to price of output.
Okay. No, yeah.
you have this-
So
We produce this Y. I could draw another diagram. This is a flow chart
Interesting.
that you have. Again, let's look at our original model so we can remember how this works. So there's the model we have. So this is going to be. So this is the value. This is macro output. Not macro. This is non-energy output. Energy supply. Well, those are the output markets. And then we have labor, capital, and energy resources. So this is labor, capital, and other resources. And now I could add to this thing, I could add something, I could say, oh, I want to look at what happens to labor supply. So let's do a report of labor supply. So that's going to be, and let's just call that LS. And that would be, so labor supply, if I look at and the way to write down a quantity is to look at the corresponding market. So my market for labor supply is going to be Y dot L. Oh wait, I have to do it on dot L. y dot L times A PL to Y, that's the input, divided by what's the benchmark labor supply is going to be equal to 60
Yeah.
minus 1.
To get the percent.
And then I put in a small value if it's actually 0.
Okay.
So it means if I'm at the 0 level, then give me a small value. So this gives me,
Why are you doing that?
just so in the pivot chart, I want to be able to have a 0 there. Otherwise, GAMS,
Oh,
I say
you're
move
going
the
the other way.
numbers.
I
I
got it.
say move the numbers into Excel, then it just won't, anything that's a 0 won't get moved. And Excel distinguishes between there being an empty cell or being a 0 are different in Excel.
You're saying because it will give you that dot. If you
Yeah.
pull that in Excel, it'll just be a blank.
I could have put an
You
F's
want-
in there and then converted the F's to 0, but here I'm being,
I get it. I get
it's
it.
just a
You just
different-
want the zeros.
I just want some zeros in there.
Okay, that makes sense. I got it. I just wanted to make sure I understand why.
That's what happens to labor supply, and then the rest of it's going to be what happens to leisure, right? So there's going to be a labor supply. So let's just quickly run this guy. But so okay, so let me just verify this guy works. GAMS energy model. And then if I look at what happens, I'm curious actually how much this falls off. I'm sure it's a lot. So labor supply goes down by 9%. 9.7%.
Sorry, where am I looking? Oh, right there.
Yeah, so at a 80%. It's
Okay,
not so much this
interesting.
is realistic. We have to function on like what actually are the value shares. We have to calibrate stuff. Does this make sense? What's happening here? You oftentimes, when you work on climate, you worry a lot about what happens in the electricity sector, what technologies back off, how are you generating electricity, how do you
Mhm.
cover the load curve? Like there's all sorts of details you get drawn into. But the basic idea here, this has got the key ideas. The diagram I drew at the beginning is we got a supply curve and demand curve for energy. If they're both inelastic, we have to have a high price to get there. If they're elastic, then we have a low price. But now, I want to be calm and just go say, now we have a model.
Mhm.
What's the most interesting answer to any question in economics?
It depends.
So now we want to think about, we take the model and want to know how does it depend?
Yeah.
And I want to think about the supply elasticity and the
Yeah.
demand
Does
elasticity.
it say, can you change the elasticities?
So now I'm going to show you how to take a model and instrument it. And again, this is what's different from Jim. Jim's approach is always put the parameter model, make a loop, do something awkward in there. I say, no, just write the model to do your solve once. Do your one solve.
So what would Jim loop here though? Like the
It'd
elasticity
loop-
of
oh, the
something?
elasticity.
Okay,
Pick-
and then see all the different outcomes.
So, but the more modern way and the way that works better with large scale modeling is to generate a batch file that then generates the solution. So
This is what you're saying about overnight.
yeah. So we do energy, and you want it to overnight, but you don't want to waste the evening, right? You want to have it,
Yeah. Yeah. No, but you're saying if you did the loop, it would
If
stop.
there's something wrong, then 12 hours later, you just don't find any output. And if you do it this way, you just see FIFO that you can produce.
That's right.
so here we're gonna now I'm teaching you more GAM stuff. I know that you guys have had enough GAM stuff. You're like up to here in GAM stuff and more GAM stuff. This is the way you instrument a model, and it's ultra cool
Okay.
because from the command line, it's ultra powerful.
And all you mean by instrument is just do this loop, but in a better way.
No, here instrumenting the model so I can control the program. I want to make the program so that when I run the program, I can tell it what value to do for epsilon.
Okay. So when you run it, you could just be like, do this through this model.
I'm going to say run the model and make epsilon equal to 1.5 and make eta equal to 2.
Okay.
Okay. Okay. So I'm going to say if, and this is a little macro language that's built inside of GAMS. If not set eta 0.5.
Okay. So if you don't set eta,
If
set
eta
it,
is not set,
set it
Set
at
it to 0.5.
and this gives me now a string substitution called eta.
I see. Okay. Can you do the same thing with
And then I look at my other elasticity. What was my elasticity there?
for demand?
And it's
signal?
easy to change the value.
Okay, so here I want to make this guy be eta. Let's call this guy sigma. So replace 0.5 with sigma. So I'm just instrumenting the model.
Hmm.
That one I don't. Those are different.
You gotta be careful.
This guy is the same. And now I have sigma.
totals.
Yeah.
And do we deal with,
That's both for Y and for C, right? It fits on two
Oh, I
sides.
see. So originally you would just put the value in. Now
Yeah.
you're creating it so you can, I see, make it a variable basically.
It's not that, this is
Not really
not so
variable.
important, but it's just basically to motivate you. Oh, yeah, I can do this. I can run lots of different models, right?
Mhm.
And we use that a lot in VBC code, so it's good for you to learn
Yeah.
what it means.
Okay, so now all you've done is you said, if I don't give it a value, make it 0.5. So
Yeah.
how do you actually make it change?
First thing is, the first thing in this game is we say copy energy model dot list. The backup dot list.
Mhm.
And then I say, and I go and save this guy, and I say GAMS energy model. Because the first thing I want to see is that I didn't screw it up.
Yeah, it actually runs still.
And I want to have the same value for my better.
Yeah.
So if I look at my listening file here, there's this guy, they look very similar.
Let's see.
It looks about the same. 5.5 and 7.94. That's also, those are all the same.
Well, the ones I remember are the 80s. So 21 and yeah, that looks right. Oh, you're comparing them. So wait, oh, this the bottom, our new one?
Yeah, the bottom is, they're the same though, because if I look at 80, I go in at 80, that's the same.
Oh, yeah, they're okay.
Okay, so now I'm gonna say, now I'm gonna do, again, I could just do this by hand to write a batch file, but I'm gonna show you how to do it in a way that's easily generalizable, right?
Mhm.
So it's gonna be, I'm gonna write a program called, and I'm just using GAMS to do this. Batgen,
That Jan?
A to V. And I'm gonna say, this is the value of energy supply. Let's call this guy 0.25, 0.5, 1, and 2. Okay, those are 4 values of
Oh,
that.
yeah.
Sigma V. And this guy is a little bit more. Oh, I know it's not, it's 0.25, 0.5, 0.75. Okay, so I've declared sets of what the values are. Why do I put those guys in quotes? Is because if I declare a set and then I give value, label dot label, it thinks it's a two-dimensional set. So you have to put it in quotes so you read it as one value at a time. So this is the values of eta.
and they don't have to be equal. So
Yeah.
we gave 4 values to Ida and 3 values to,
Now let's
Sigma.
remove the 0 dot. Let's just put them like this: 0, 50, 100, and 200. That way we don't have to mess around with the dots. So that way like this. So we know what the values are. And then if we go in here,
Yeah, because just gonna run 25 on 0.25, 25 on that. You see what I mean?
okay,
That's why they don't have to be equal. So 25 is gonna run on all 3 of those. 50 is gonna run on all 3 of those. 100 is gonna run on all 3 of those. 200, right, Tom?
yeah,
And then 25 is gonna run on 50.
yeah. We'll do a loop
50 is
over all
gonna
of
run
them.
on
right?
50. You see what I mean? It's just
Mhm.
gonna be combinations of those.
So you have
Set.
4 times 3 combinations.
Yeah, exactly,
Yeah.
exactly.
Now here I'm just to avoid having to mess with the dot in the thing. I'm going to say convert from percent to level to value. So that's going to be eta is equal to eta divided by 100, and sigma is equal to sigma divided by 100. So that way I can use 25 as 0.25 and so forth. That way I have a simpler set
I
of
get it.
numbers. So so this is values of eta,
Wait, explain, why did you do that? Why does that matter?
because I'm going to save the output into files that use this name as the prefix.
Okay.
And that's because I'm showing you another piece of magic.
Okay. One piece of magic at a time, but all right.
That is crazy Tom magic.
I mean, I see what you did. I just don't understand why it matters, but Go
Okay,
ahead.
just watch.
okay.
This is cool magic.
It's getting late. Tom's getting.
No, it's almost time. Oh, no, we're going to, this is the great
We
point.
have time until 4.
No, I'm joking. I'm just saying.
File.
He's gotta get his fix in for the day.
Yeah, Jim always makes fun of me.
He loves it. The dynamic between them is great.
That label width equals 0. Put K back. So this is where we get part of the magic we get here is we're gonna write a little file. We're gonna write a batch file to do everything, because I want to write the file. Part of it is I could run it all from GAMS, but I like to write the file because then I can look at the file. I could say, does this make sense? Can I run it? So I'm gonna say, okay, I'm ready to run this guy. I'm gonna, so let's put in that. So put GAMS.
Put command writes something to a file, and he declared the file kbat.
Mhm.
So this will be written into that kbat file.
Okay.
Data B. Oh wait, here I can actually I can avoid this. Let's see.
Why do I have GAMS 2 times? GAMS energy model.
I didn't mean to. My mistake. I can do this without. I can make this like this because I can divide at this point. When I run the thing out, I can do this. So I don't need these guys. I can, within the model, I can write it. So this is going to be eta v dot val divided by 100.
Mm.
And this is going to be, and I have to say kbat dot numeric width, num decimals equal to 2, and kbat dot numeric width is equal to 0. So I'm just doing a little bit of programming stuff for formatting and stuff, and I'll say dash dash sigma is equal to sigma v dot val divided by 100.
Okay, so you're doing the division there instead of what you got it before.
That's right,
all.
and that
All right.
way everything will be fine.
Mhm.
And now I want to say, let's just say, say GDX, or let's say, just for funny, we'll say output equals eta b dot TL dot sigma v dot TL dot LSD. So there I've generated the output. So this is, I know it's tedious and I apologize for being tedious, but the key thing is I'm thinking about stuff that's useful to learn. And this is something you say, well, I'm going to learn this 2 years from now. But the fact is that if I deliver a model to you guys to do stuff, this is the way I would generate this thing to generate.
Okay, then
simulations.
if that's the way, okay, so I get the sigma, what you're doing, I get the eta, what is O?
Output
Output,
The
and then,
output file.
and then,
dot LSD at the end.
LST and UT is missing. No,
oh,
it's there.
okay, I see it, okay, that was, okay.
I do the font. Here you can see it.
Yeah, it's actually, that's helpful. Yeah, it's small.
Title
Okay.
a file, a batch file. Run a bunch of cases. Okay, so it doesn't, we don't have to do anything fancy here. Let's say GAMS batch end. And then so solves.bat is what gets generated. There's my set of solves for all of them. In this case, I could just have written this by hand,
Mhm.
but I'm just showing you how we do it in
Mhm.
practice, right? In practice with a large model. Because the thing is, as soon as you get a model running for a real issue, the number of variants of the model you want to do, you get to start to accumulate control parameters. And you say, well, I want to do a group over them. And if it's just because you're going to bed at night, you can run all of them. And then you can get up in the morning, you can pick what you want to. The beauty of having a pivot approach is that you can look at anything you want
Yeah,
to.
you technically could run right from 0.01 all the way to 2 on both of these elasticities, right?
Yeah.
That would be a massive.
You can do all sorts of stuff, right? So you can basically, it's very easy to generate pivot tables that's got 10 different characteristics
Yeah.
across them. So it makes it possible to, and the whole point is the machines are powerful. So doing this, and I haven't shown you yet how to get them to launch them so you get 8 of them going at a time. So the cool thing is you can launch it so that maximum 8 is going at a time.
Mhm.
And that way your machine is still usable, but you're solving 8 in parallel in the background.
I see.
So you can basically set it up so you're really taking advantage.
So now how do we punch these out to look at them all?
That's what I'm going to show you next.
Okay.
So that's the piece of magic. I'm first going to verify though that this works. So I'm going to say solves. So that guy, and here I'm doing it all in parallel, in serial. So this is slower than it needs to be.
So this is doing each one of these.
Mhm.
Okay.
And each of them is doing 80, right?
Mhm.
So we're doing are doing a bunch of scenarios for each one. So it's there's a lot of solves, and I haven't turned off the solver, so there's things we could do to make this specific one, I could make it really go fast, but more I'm just trying to show you, and it's always this thing of like, you want to learn how to build a really big model, let's first learn how to write reports,
Yeah.
and then let's learn how to launch a bunch of scenarios. So basically to get you equipped, so when you get a model that operates, you know how to control it, right? It's all about, like, I want to control this model so I can tell it what to do and I know what's coming back. right?
Yeah, exactly. And then you can get some takeaways.
Yeah, and you can immediately you can understand something from the model.
Yeah.
Whereas otherwise, if you spend all your time focusing on, oh, how do I write this equation? What do I do there? Then you don't get to the important stuff first, whereas you want to get a small, simple model running and boom.
Yeah.
And then the point being that you can't guess ex ante what's important to work on. It's the process of interrogating an existing model, figure out where the biggest weakness is, and just fix the thing that you find that's worse. So you can basically get something running and then make sense of it. So here I have all the different runs. So we see here's got the cases. If I look at what is going on at the bottom, so let's just look at the 80.
Oh, is
case.
this your list file of all the?
Yeah. So that's 2. And now I go down to the bottom one.
Oh gosh, they got a bunch of them now.
So with a very low elasticity, output falls by 53%. This is low,
Mm-hmm.
and this is high. So high elasticities, the price of carbon is essentially 1. So basically the price, if they're both elastic, so the price fills the whole thing.
Yeah.
And the output falls by 11%, whereas in the low case, the output falls by 53%. In both cases, energy is declining by 80%. In the low case, the energy price has to go up to 3,000, and the other one goes to 650, right? So this is getting a sense about what happens across the market. I'm just looking at these 2 runs.
Hold on, I see you. I hear you. I'm just trying to internalize it. So on the low case, you're gonna have very inelastic supply and demand curves, right?
Yeah.
I see. And so the price has to go through the roof.
Yeah.
The price of energy, and then and then you're gonna have, okay. So going back to your, it's not there anymore, your chart, it would be the
Also, stick one versus
Yeah.
the following.
and so that's kind of what we're looking at here, at the 80 case.
Right.
I get that, but.
And labor supply in the highly inelastic case, labor supply contraction of a 50% contraction labor supply, and the other one you have a 3%. Right?
Yeah.
So it's a big difference. I mean, we haven't parameterized the model, but the thing that's cool is that you get a feeling for what you're able to do, right? How you can change stuff that matters, and then the whole thing is to be able to control the model. It's like, okay, the model runs, boom, I'm gonna like hit it and get it to do stuff. Now we have to do the stuff that's a little bit techy. This is something that Martha will roll her eyes at me for doing this. So I'm gonna say, the things I want to add here is going to be make a directory, and that's going to be GDX output. And then I'm going to say make a directory. What's the one that has the smallest number? It's going to be 25. Uh, 50. 100. And 200. Okay, so that's what this one is. And now I'm going to I'm showing off.
Okay.
Well,
That's
you
fine.
weren't
You don't mind
showing
if I-
off till now, and it's just starting.
No, I'm-
I'm quite curious.
This is the beginning of it?
This is Control X, remember what I'm doing,
Yeah.
go to the end of the line, go back 2 lines, grab that puppy right there, go to the end,
Okay.
write down GDX equals GDX output / reverse search for underscore
Really?
/ dot GDX. Go back to the next line. What's what I do? That's what I do. Boom.
Oh, it just, pulled them all.
I just said do it.
You
Do it
told
10 more
to
times.
speak up to
I
that.
did it once carefully, telling it how to do it,
Mhm.
and then I just said Control U, do it 9 times.
Can you show it again? Can you show how you did it? Sorry, I thought I was completely
This is-
lost. So
that is the power of the editor.
Yeah.
Oh, okay, so
You
we can't
you
really do
can't
that
do it
in the studio,
No,
okay.
that's the
I-
power.
No, in studio you can't. I'm just showing you what you can do
Okay.
with an editor.
That's the power of the editor.
But
Okay.
I'm just trying to share with you that it's these little things.
Yeah.
That saves a lot of.
Well, you would
time.
have to type that
That's the reason
out,
I
like
say,
that.
learn the editor, increase lifetime income by $50,000, easy.
Yeah.
It's not even about expropriating money. It's just about your own time savings, right? You sit down to do something. And the thing with the editor is you're always thinking, okay, what am I doing that's mundane? How could I make this go faster? And this is the sort of thing I do all the time. Like this is quick and dirty. Now I've created these outputs, and then now I'm going to say at that point, now I'm going to run the thing, and then that looks fine. So let's just say solves again. Oh, and let me do something else. I'll show you how to do this. I'm going to say start. So now I've started all of them, and that basically runs them all in parallel.
Mhm.
The start command, if you haven't learned it already, this is your friend if you're working the command line. Because start makes you says, launch that one. Okay, come back to me. Here, launch another one, right?
Mhm.
So you're throwing them out there to run in parallel. And so 1, 2, 3, 4, 5, 6, 7, 8. Okay, we won't start that one that way. We'll run that one in parallel. So we'll start 7 of them, they're off running. Then we do one, it'll wait for that one to solve, and then it'll go and do another 8.
Mm.
Right? So
Hmm.
that way, I'm basically running around 8 at a time. Goes out to do it. And the beauty of this is then if we say solves, they all are running in parallel.
Oh, yeah.
And so your time goes a lot faster. Again, this is like stupid geeky stuff, but this is the sort of stuff, if you're going to use GAMS, you're going to basically innovate and do stuff. This is the way you, the guys who are using Genpack and they're using Run Genpack, this is where you're killing it, right?
Mhm, yeah.
Your control is so much more varied. Now, on the other hand, maybe you don't want to learn everything. You have to pick, you have a list of things you can learn and you have to decide what it is from the list. But if I'm working with you, I deliver a model, this is the way I'll package the thing.
Mhm. So it's good to see the way you do
This
it.
is the way I
yeah.
package stuff.
Hmm.
And now what I'm going to say is, if I look at my TDX files output, there's 3 there, there's 3 there, there's 3 there, there's 3 there.
Mhm.
Now this is more magic. It's ID is equal to that, pivot data, output equals, okay. So I've just written,
You just see Jim smiling right now.
Well, Tom's smiling too.
it's fine. So it's pivot report, so GDX merge. It's going to be,
It's actually quite nice to see how much you enjoy this, even after like working on this for like how many years? I don't wanna, like maybe
40 years.
40 years, yeah.
So pivot report was the item that we're doing.
Mhm.
Output equals GDX output.
Now you merge all the GDX files in the
Mhm.
directory 25.
Yeah, that makes sense.
And
So
then
yeah,
you have just one GDX.
the little
file.
asterisk is going to run it through them all, right?
Mhm.
So if I look at this is saying, and again, this is batch file programming. I'm going to say echo off. I'll go to. So that goes like that, right?
Mhm.
I've been at this for a long time. It's kind of embarrassing, actually. I had my in 1992, maybe, or maybe 93. No, it's after. So it's 94. I did a project with the World Bank in Tunisia. I don't know my French. My Nepali is very good. My French is bad. My Arabic is non-existent. And so I took I had my IBM portable computer with me, and I had some portable computer. Let's just see if this works. Solves. So it reads the file and the output. If I look at what I get now from GDX report or output, now I've got there's the file of results. And now we just do this for all of them. Solve for that. So it's going to be 25, 50, 100, and 200. Output equals pivot report GDX. XLS. X par equals pivot report. Range equals pivot data. Bang A2. CDIM is equal to 0. Int as text equals no. So what I've done is I've grabbed the results from each of the 4 cases, pulled them
Yeah.
all together, moved them together. So every time I do the UX merge, it adds the name of the file name as an index. So you're going to see how this looks. If we say solves, pivot report. Report.xlsx.
Yeah. The other way.
Now it's going to be, I got to remember which was which. This guy goes up to, wait a minute, something's wrong here. Oh, I have something wrong. One second.
Yeah.
Oh, yeah, that's right. This guy should be 50. This guy
70.
should be 100.
200, right?
200 on the last one, right?
So that's it. So now we have the runs together. And now we have numbers 1. Let's look at what I've got here. Data. Filter. Yeah, okay,
Yeah,
that's
okay, there you go.
25, 50, 100.
So
What was
that's
the
your-
one was that Ada or was that?
I think that's Ada, right?
Yeah, that's Ada, that's the energy supply, and this is Sigma.
Yeah.
So if I say data, I can turn off this guy, turn off this
Just label
filter.
them, right?
So this is going to be Ada, this is Sigma,
That's the
This is-
abatement, right?
that's the CLIM item value, right?
Yeah.
So then I have, and it's not so much, I'm just trying to share with you what the methods are. what the
Mhm.
method is. It's like, okay, so I'm going to say then I highlight this guy. I say insert pivot chart and table,
Mhm.
go like that. Then I can grab this guy has to get out of here. So I'm going to have the value goes down here. Let's say the item, I'm going to look at that one on the page. I look at the climate, the limit is going to go like that. I'm going to take Sigma and put it over here. I'm going to put Ada and put it like, well, Sigma, let's just put Sigma over here. And then you can say design chart.
Yeah.
And then I can look, say, okay, well, what is the range? I can say, look, what happens to labor supply?
Mhm.
And now you can look and we can say basically grab stuff on the axis. Let's say labels. So elasticity from 0.25 inelastic. And we see that the biggest effect is on the demand side, or the demand side, whereas within each group, there's not as much, there's some variation. The supply response matters, but it's not as much of an issue.
Yeah.
So it basically has a way of comparing, and this is looking across output. We could pick a different output. We could say what happens, for example, to the carbon price. And that shows what they are. And this has to do with this is looking at elasticity supply. So basically you can mess around.
Yeah, these are just different combinations of
different
the,
combinations.
yeah, I see.
And this is where the thing is, the skill set that comes at this point of producing a nice data model that illustrates things with documentation and cleanness. That's something that's very easily delegated to somebody who's an assistant in the office. That doesn't require a lot of expertise on the modeling front. And that's the reason in a government or business environment, it's really good to team up someone who's good with this, with the Excel end on the visualization and also is aware of the policy dimensions, because then it's ideal to have three people. You have someone who's high up, who's basically the guy who's negotiating with, present the stuff. You have someone who gets the visualization together, and the guy who runs the model. So the model gets generated. You have to get good at this process of how do I pump the stuff through, stiff the stuff into a spreadsheet, or sometimes they get bigger than you can handle a spreadsheet to move the stuff into a CSV file. And
Yeah.
then someone else has a visualization, and then you have an ongoing dialogue with the model.
Mhm.
And the idea is always build a model simple at the beginning. It's like simplest possible model, then we'll make it gradually more complicated. And you are, if you use that strategy, you're never surprised by the fact that your model is stupid, because all models are approximations. They're all stupid in some way. You don't want to wait until there's this tendency, if you hold back on getting a model working, then you raise expectations way too high. And then when you produce the numbers, then there's this crashing disapproval of the fact that the model doesn't make sense. Whereas instead, if you simply take the issue, get a model running, get some runs together, share that, identify where the problems are, and start this process of, it's a continual process going back around, then that's a much better routine for making stuff work. But this process of how to get the models so you have control over it, identifying what inputs do I want to control. You have to have a flexible tool for generating the script to launch it, and all the stuff I did by hand here, I can put that into my batch generation thing.
So say we didn't want to do the batch, all that though. Could we just run a loop and still get this report to pump out?
So if the model is such that you're reliable, you know that it will solve. So let me show you how you do it inside the other framework. So if I go, yes, the answer is yes. The old-fashioned way also is.
Yeah, that's what I mean. And if you do the gym way,
So I do the gym energy model.gms. So there's the model. Let me just move this thing out of my way.
not that, we need to be old fashioned. I'm just curious.
So this way, so here I would still have the model be a one-shot.
Mhm.
Let's say GAMS energy model, and this is the other way of doing it. This is the old-fashioned way of doing it. Save equals ref.
Mhm.
So it does 100 cases. I've saved it at the end, right? And now I say SSA, systematic sensitivity analysis.gms. And now I go to my other file. My batch.gen file, and I have these values. Loop over those guys. I have eta is equal to eta b dot val by 100. Sigma equals sigma b dot val divided by 100. And now the thing is, what's Hesse here is that these guys are calibration parameters, so I have to recalibrate the model at this point. So I have to say, where does eta go in? Oh, so eta only goes in there. That's okay. And where does sigma go? Well, that only goes in there too, so that's all fine.
So yeah.
If not set, no loop. Set, no loop. Equal to no. No, let's just say exit at this point.
Thinking of
Now we can just do it this way. So here we do the whole loop. And this would be loop over these guys. And then, so now I'm going to just grab the loop I'd run before. And
Mhm.
now I'm going to basically say, load point, solve energy, and now I'm going to say A, I want to save this by eta V sigma V. That saves everything in that format, and then down below we generate the file. So now now I have a loop with the whole thing, right? So if I go back to my model, energy model, I'm going to look back. I'm exiting at that point, so I'm no longer doing the loop. So if I go into here, SSA, I'll just say run the energy model. No loop over scenarios. So now I create it, and then I have this loop over stuff we're going to be chasing. So we have abatement target, eta value, sigma value. That's all the stuff. We have the parameter for what consumer. Oh, same as. Oh, so this is going to be like this. I'm sorry. So now it's one. So now it's not running in parallel, but it will run through.
It's just looping them all.
I'm going to interrupt it because I didn't say save.
Go back to the pivot table one more second. All right, so
This guy, I need to put some labels on things. The 0.25, 0.5, and 0.75 are elasticities of energy demand,
yeah,
and the others are the elasticities of energy supply.
supply, yeah.
So both sides, they have the same effect, but basically the energy demand elasticity has a lot more leverage here. W is going to be welfare. You see the welfare cost.
And so basically, if we do this, we'd be tanking ourselves.
Yeah. There's lots of stuff that's possible.
Yeah.
But the thing is that, okay, so we're interested in doing border carbon adjustments, but important to bear in mind here is that border carbon adjustments, the effects of those are driven entirely by what is the energy policy you're doing inside the border, right? Like if the tax locally is small, then it's not as much effect. So we'll go through and do this sort of thing where we can change the supply side, what happens to supply of energy and demand for energy, as to what the target is. The main challenge in this sort of simulation work is that what's in climate modeling these days is that this policy, I regard most of the policy that's discussed as aspirational, because anytime the target is something that's beyond the political horizon of promulgating a policy, they have nothing at stake.
Yeah.
So they're happy to talk about very grandiose objectives, but no, they never want to do anything in the near term. So it makes it you as the analyst of the policy, you're sort of responsible for saying the emperor has no clothes, because you say you want to go back to 80% cut back by 2030, or
Yeah. Here's
say,
what you
well, the
have.
carbon price is going to be $5,000.
Yeah.
And that's the reason why I bring in this thing about
50% output.
these backstops things. It's really helpful to make an assumption about some technology that can come in. And that way you don't have to be because in some sense it's hard to defend these numbers because they're so huge that it's clearly not, the simulation you're doing is outside the domain of what the functions are. This is sort of a crash course in energy.
No, it's fine. So this little model, though, you could add more technologies in.
Oh, sure, we could do that most fun.
I mean, you don't have to do it right the same. Where would you start with that, though?
So if I look at the
Because yeah, no sweat.
no, in the model it's very easy. So if we go into our model,
Can you zoom out just a little? Just in the sense of I want to see a little bit more code. Hopefully people on there can see. Yeah, just like where you are in the model. Does that make sense?
yeah, so there's the way this goes is the top I have the controls.
Yeah, all that stuff.
I have some text with this thing. I have the declaration of what the parameters are. And then I have the declaration of things. And I'm going to put in here non-negative variable. I'm going to say T will be energy technology. A backstop.
Okay, let me ask it. Now it's my turn to kind of ask just stupid things, but so the macros, you're just basically defining. Go to one of those macros just so I understand what's going on there. You're basically just saying you can call one of them X, and then you're writing the equation, and then you can just use X wherever you want. And so you don't have to keep rewriting whatever sigma square, whatever all that crap.
I
You know,
think it's the same thing as state out, like, do you use macros in state out?
not really, no.
Okay.
The main reason is that this is a.
But I
teaching-
see the point here, because you don't want to have to write out, like, for example, the macro for consumption C is, you'd have to write that out every time, right?
Yeah, but the thing is, if you substitute these guys in this little equation, then you get one of Marx's models. That's, I don't. for
Oh,
teaching
you're saying
purposes,
if you go sub that all in, then you
That's
get.
the way Jim's models always have all the algebra in them.
Yeah, they do, yeah.
And it makes it, for me anyway, it makes it really hard for my eye to parse what's happening.
No, I agree. I just wanted to make sure I understood.
So what
The
that
use
does
of
is a
them-
straight string substitution. It
Yeah.
says,
Yeah, I get it. Because you'll just take that and you would just put it in that way. Like you're saying, Marcus's model just had all this written out for every single equation.
yeah,
Okay,
that's old school GAMS. Macros have only been around for whatever, 6 years or 7 years. So there's Jim predates this, so it's not something. And not to criticize him, it's just, this is the way, you have your own way of doing it.
no, that's not, yeah.
But I'm finding myself that the macro approach gives you a lot of power, and it's mainly this realization that you don't have to write down the revenue function, you can just simply write down, sum up the coefficients.
So in that like simple little exercise one, for example, for the production function, you could have just written like macro production, and then you did L, what was it, L to the alpha?
Yeah, you could
And then throughout the whole thing, you could just use,
use F.
yeah, whatever, yeah, exactly, whatever you defined it as. Okay, yeah, no, just checking. Okay, let's now enter the other thing, which is for you to bring a technology in.
So if we have a technology, then we have to have a set, we have to declare a variable that represents supply. And let's give them some data. Let's say parameter is going to be cost. Max share. So of energy supply.
Yeah,
It's a sort of thing. There's some sort of blending constraint on how much you can do.
how much you could take.
So that's a
over, yeah.
quantity and a price constraint on the variable. And then we have this, we declare this as a variable called X at T,
Mhm.
backstop energy. And now we're moving out of the energy,
Did you just add the set T in there?
yeah, I declared set as the backstop energy technologies.
A minute ago before I asked the
Yeah.
macro question. Okay,
Yeah.
I missed that. So
So
that's where
T1
you're setting up all these different technologies.
So I just defined, and
Okay,
in practice, technologies, again, it's like you were saying, you like working with the USDA data, you get over Department of Energy, you like technologies, you got technologies, we got to give you lots of technologies. The hard part is like, what prevents them from coming in? In a model that's optimization based,
hmm
you want to assume that these technologies don't break even today.
Yeah.
Otherwise, you have a problem violating your principle is that people are maximizing profit. If this technology is around, is cheaper than available thing, why is it?
Why is it not being used? Yeah, I get it.
And then you also might want to think about there being carbon free.
Yeah,
these
because
guys
that's the
are-
point is you can replace the carbon
replace the
technology
carbon,
with
right?
with.
So
the
this guy,
carbon-free.
so these guys are all in there. We can have the cost of T. Okay, so generate some random statistics. Random technologies. So cost of T is equal to uniform of say from 1 to say it's equal to 1 plus uniform of 0 to 4.
Okay, so you're just giving it a random.
It goes up to 5.
Yeah,
it starts
get
at
it.
1. And then we'll say max share of T is equal to uniform of 0 to say 0.2 or 0.3.
So it can only take up to 30%.
of the energy.
Oh, yeah, okay.
Okay, so that's the basic. the
Yeah, I
basic
see.
Budget. Now, the thing that's tricky is implementing that guy, what the shadow price is. There's gonna be Q of T will be the shadow price on the share constraint.
And the shadow price is basically what the price it is to offer this in the market. And that's got to be up above, like you
No,
were
but
just saying.
this shadow price here is gonna be the fact that when you hit your upper bound of capacity, then can be a wedge between what your cost would be of supplying and what the market value is.
Okay.
So there's gonna be a limit that says that you're gonna have a constraint that says, it's gonna say, I don't know whether you guys are enjoying this afternoon. This is exactly what I had in mind.
No, this is perfect. I think
This
that-
is, before I dived into the big complicated model with all the sets and stuff, I wanted to face.
you're going to send this to us. Though.
Yeah.
I want
Will you
to.
stop sharing your screen, please?
Oh, yeah, sure.
I think. Oh yeah, I guess.
I don't know if people are out there. I haven't heard anybody. so
Oh, yes. There
I
are
don't know, I
several.
don't know how we're doing. We're just sort of, we're going down this rabbit hole, but I think it's a good one to go down. It's like, the whole thing is what is an energy model? And I'm trying to give you a sort of a rapid fire introduction to what the issue is.
No, this is helpful. If you could share it, I think Gubin and I are just gonna like play around with it tonight,
Yeah.
right?
Mhm.
So then we
That's our
say,
plan.
so here we're gonna have a thing that says it's gonna be E, that's the conventional energy, plus the sum over T of X of T has got to be greater than or equal to A Y or AEY times Y plus AE consumption times consumption, right? So this is final demand, or no, it's gonna be, we have an uncompensated demand, so demand of E. So that's final demand, and there's intermediate demand, and here we have this supply, right?
Mm-hmm.
Right, so that, and then we have a constraint that says that X of T, no, I'm sorry, the sum, so it's gonna be theta bar sub T times E bar E plus the sum over T of X of T must be greater or equal to X of T. Because T prime says all, this is all output. That's the conventional energy, and that's the maximum share. This is share constraint.
Sure. Okay.
So how much, so that's the way, you could put in a simple upper bound, but I think that share constraint is more, that's sort of like, that's the way it, if you think about renewable penetration, that's the way it sort of works. It's like more, it's what fraction of the supply you can
You can
get
take
from
over.
wind. It's like there's a certain fraction of the day where wind's
Yeah.
available, so that the share constraint is more sort of consistent with solar or wind constraints, as I think about it.
Yeah. No. I see
So
what you mean.
there's-
There's only so much you could.
There's a constraint. So therefore, this guy will have a shadow price, which we're calling Q sub T,
Mm-hmm.
and we're gonna have a constraint that says, so this guy is gonna be the shadow price for PE. And then we're gonna have an arbitrage condition for X will be is gonna be Q sub T plus C sub T times shadow price. I'm assuming the macro output goes into, that's Q sub T, that's the cost of supplying, has to be greater than or equal to PE, that's the value of the energy that they produce, plus the sum over T prime of Q sub T prime, like that. Let's see. Oh, I'm sorry, this should be times theta sub T prime. Because the thing is, you think about what the values are. If we operate X, X gives us an additional unit of capacity for all the other guys. This says, this is the amount, this says that every X will generate additional capacity for the other guys. So there's a shadow price that has to do with what the benefits are. So what you're generating is additional capacity, and that makes it possible to relax the constraints in some of these other guys, and you also produce energy. And the same thing goes for E. E will have different constraints here. So let me just write down, I'll write down the model. And you can look at it.
Okay. Yeah.
So if we go this guy, this is the shadow price on the share constraint. Let me just go up here and I'm going to say alias T on TT. So constraint, and then we're going to say here, say what's the sum over T of its Q of T. Let me just remember what it was called max share. Now let's call it MX mu. Let's call it mu as the maximum capacity. Mu of T times Q of T. There I'm going to say profit. So X of T. And that's going to say P times, let's call this guy, do we have a C already? I can't remember if we have a C. Maybe we'll call it C as an XI. So P times XI of T plus the sum over up must be plus Q of T. That's the value, that's the shadow price capacity, must be greater than or equal to PE would it be X? So that's the energy plus the X. So there's the X and there's the demand. And then if I look at profit for X, it's going to be PE plus the sum over all of the technologies TT of mu of TT times Q of TT. Because when I produce more energy or I produce more renewables, I also produce that generates more potential capacity for the other outputs. So that's this effect of the sharing constraint. And that should be such that if the C's are sufficiently high at the benchmark, all the X's should be equal to 0 at the initial point. So it says here we're going to say Q dot L of T is equal to 0 and X dot L of T is equal to 0. Right?
That's the same.
So now we verify that we want to calibrate. Oh, we have to say profit X dot X. So that gives us the shadow price of these guys of market profit X. And I've used this C and mu are the two parameters to cost. We're almost done here. So I need to have C because we have to have market for Y. This is going to have plus the sum over T, C of T times X of T, because we have to basically, there's the demand for output from Y either goes into energy costs, conventional energy costs, renewable energy costs, or final demand. So, I don't think I'm using these guys. I thought I'd use this. So,
We're not able to see your screen.
no, I'm sorry. Yeah, I'm
You
sure.
need to make it larger again.
I'm afraid I thought
Oh, and you don't share your screen right now. I'm sorry, I didn't tell you.
my fault. My fault.
No problem.
Thank you, Nabil.
Can you share your screen?
Yeah, I'm doing that right
That's
now. I'm trying to understand what happened here. TK, I had a bunch of stuff in here that I wasn't using. Okay, so let's see what else I have here. Okay, unmatched variable, I forgot to put this guy in, so Q goes in. That's market, oh, we have to have a market Q, so it's gonna say here, it's gonna be market Q, I forgot to say, market Q of T. And that's this constraint here that says that the maximum share is mu of T times 10 times E plus the sum over T of TT of X of TT, that's the total energy supply, must be greater than or equal to X of TT. So that's market Q. Q. This guy should be market Q, I'm sorry, market Q dot Q. So now it's iteration limit 0. So now that all works. And now if I do the full, let's do the full thing. So this is going to be SSA. And I've not put an SSA on what the cost of the technologies are, but let's just say execute, unload, pivot, report dot GDX, pivot report.
Just running all those scenarios.
For every single case. Yeah.
Okay.
So there's 12 times 80.
And so will this show us when the technology comes in now?
Yeah, and I think what I can do is go in the Excel file and move over the ones with no technology and put in these guys next to it.
Okay,
So
yeah.
we'll have an additional, we can put an additional tab in.
Tab in.
I'm just doing it cheap. I'll do it cheap and dirty. I'll just move it up by here.
Huh.
So this way you could make an assumption of what the cost coefficients are. And so this way it's very easy to have a technology. So the thing is, this is equivalent to a technology which doesn't break even. So it's outside the budget line at the benchmark point.
Mm-hmm.
But as you start to move up, it prevents it because I mean, essentially the idea here is that the way this looks is you think about it as though, so this is going to be energy, and this will be capital, labor, other goods, or think about that, whatever, there's other stuff. So it goes like that. And we have a benchmark point where we have the initial equilibrium looks like this. So we got E bar, I guess call this KL bar. Or let's give you Y bar, doesn't matter, but there's a technology. So normally, if we say we want to go down to something that's down here, there's a minimum amount we can abate to begin with, and then there's something that goes like this. So now the way to think about this, although we have a technology on demand, anyway, it's the basic intuition is the same, the geometry is the same idea, is that you basically have, I put in a set of technologies. They're more complicated than the simple one, but there could be one like that.
Mm-hmm.
So that says that I can produce output through this thing, or I can produce output through that one. And so that ends up picking up the frontier, that's the isoquant for this guy, then begins here, goes around, and then it goes like that. So that's the actual frontier.
Mhm.
So it can wrap around and it can pick something up off the top. So therefore, what had been driving cost really high, it'll end up latching there, and then that'll prevent it from going. I mean, that puts the limit on how low we can go, but this should be a different run. So let's just see if we can generate. I look at pivot reports already there. So it's going to be, let's go to say this guy, let's call this guy the rename. This guy will be no tech. I'm going to delete these two guys. So delete that. So I no longer have this stuff. And then I'll say file save. And then if I look at my batch file, I go back to here, I can simply make the same command. It runs the stuff out. And now I've got no tech in this guy. And so this guy is going to be, so I'm going to say insert column. And I'm not very good at this sort of stuff. I'm going to say this is the tech model. And then I go up page to no tech, grab these guys. And then grab that one. I'm going to say this is no tech.
Mhm.
Again, just not,
Makes sense. Makes sense.
So now I have the technology. And then I go up a page, I grab the end of these guys and I have these guys. Right? And now I can pivot across these guys. I can say insert volume would go over here. Item would go down up here. We'll look at climate target would be like this. And we can look at the value of sigma. And then it's going to be sigma over here, 8 over here. And I have the item. Oh, I finally have to get to tech versus.
So where's the tech? Oh, it's up there. Okay.
Let's just go like this. No, let's take the technology and move it down below. So I don't think I can screw something up, but you get the idea.
Yeah, I get the idea. Yeah, no, this is exactly, and then you can compare the two, when
Yeah.
it would come in. At what like abatement point, right? And
Yeah.
at what combination of the elasticities.
So that way you can have, and really increasingly in worlds where you're trying to think about, this is going to be item here would be, so let's look at P carb. Right, and then this is looking at, oh, I want to look at tech and no tech. I got something wrong. It should be, I don't think I just want to have one. I have something screwed up here. I think I have some number wrong, but basically it's going to show that no difference.
But just save that file too. I want to take a look at that.
Yeah, I will. I mean, the
Okay.
thing is, it's got something, we need to set it up so we do a run with the technology and one without, or you could specify what the share is. But you basically want to make this point about the technology now. And that's exactly the point I wanted to make, is that you guys get in the game of thinking about border carbon adjustment, you want to do a simulation. You have to be a little bit aware that there's different points of view about what the cost is for the targets that are being suggested.
Yeah.
And to accommodate both sides, if you simply worry about the elasticity, you're going to quickly run out of leverage on the elasticity. If you're very optimistic about the elasticity, the targets that are being discussed are so enormous that you have to have the possibility of there being some technological
That comes in.
that comes in
Yeah.
as possible.
Otherwise, yeah.
Otherwise, you're going to have trouble explaining what you're doing. So
That's
anyway,
part-
that captures the ideas.
Yeah.
And my
Yeah.
idea on the first version is I just want to do a simple version of WinDC where I keep track of carbon. I'm going to have oil, coal, gas. We have a simple representation of electricity. And we just can do something that says, okay, because we have to have a background that says, this is the climate policy that we have in place. This is going to be, 40% by, these are the assumptions we make about backstop technologies. And this is what happens when we have border carbon adjustments. And it's just a matter of like, for the assumptions on technology, target, local elasticity, what's the overall cost? How is that cost shifted by the assumption of both of those measures? That way you have a very simple framework. And you're not asserting that you have better information, but you want to have something where if somebody else has a different opinion about what the technology should look like, you say, fine, just tell me what to put in. I can put that assumption in. Because you're going to have this interplay. The border measures matter a lot when the costs are really high. But when the costs are modest, then it doesn't really do very much for you, right? So there's this interesting interplay between how much you get from the border measure in terms of protection versus how much you get in terms of overall efficiency, and there's also this effect on global. So all of these things are interacting. If you're not sympathetic, anyway, I'm just trying to help you
No.
get oriented. This is the issue. And I think I can make this little model so it captures the essential idea. What's nice about it is this model is like three lines. There's nothing to it, but it has all of the key ideas are there, right? It's this local versus global versus. This difference between, I've always been fascinated by this difference between what's driven by the local elasticity assumption and how does that depend on the properties of a functional form. Anytime you take a functional form and you start to really go out to an extreme case, you're really skating on thin ice because you don't know, you're relying on the properties of the function very far away from the point. So the idea that the elasticities you've measured, presumably through small perturbations around the benchmark, the idea that those, it's really pretty far. Anyway, so I'll send this to you.
Yes, and please do, or to Martha, and she can.
Yeah.
But we want to play with that. I think that it makes sense to declare victory.
Yeah. No,
Yeah,
that's
but
right.
we should talk about what we're gonna do tomorrow.
Tomorrow's going to be windy sea, right?
Yeah, tomorrow's just when DC. And tomorrow morning, I begin by looking at the thing is, there's stuff about what have we done
Mm-hmm.
thus far? And then what do we want to do?
Yep.
So that's the two things. And one of the things we want to do tomorrow for sure, I want to go through the model and let you understand what do we have, like what do the models look like. And then I want to go through and say, how do we work this data set to make an aggregated version of it? I'll do that tonight, but I'll show you how to do an aggregation of the existing model.
Mm-hmm.
And then we want to do something similar to what we've done here in the simple model, in the WinDC model. I want to, at the end of the day tomorrow, before we leave, I want to have a run at maybe a small number of sectors, but I want to have all the states. I want to have a climate policy, and then I want to look at what happens when we put a border measure. I just want to do the fundamental thing. And if I don't get all the details straight, I have something that doesn't pass the laugh test, I don't care. I just want to have a run where you have a model that does that.
So we can play with it later and come with questions.
And we identify where we're off, and then we make changes and we improve things. But I just want to have a model where, just like we did in this little model, we put in a climate policy with a target.
Mm-hmm.
And I want to say, what's the distributional cost of that? How does the border measure affect the distribution of variance? I see that as the strength we're coming out with this model is we have a bottom-up sort of energy-informed database, and we have regional dimensions, and we have household dimensions. So we have a lot there in terms of distribution, and we want to make the simulation as simple and as we can. We don't want to get into this. We don't want to get a pissing match with EPA or DOE over what's the right assumption to make about this or that technology. It's like, no, you guys do that. I don't care, but I just want to look for the simplest representation, what happens in this model. And that's the paper I'd really like to write. I'd like to write papers in. So border measures play a role. There's a lot of people who have the perception that on trade policy, we've ignored distributional consequences.
Mm-hmm.
That's the common view, is that this was, and like say, well, what about border measures? Is there an argument for border measures on the basis of what it does
To distribute.
to distribution income?
Yeah, it's like the whole, it's
Geography.
like Danny Roderick's whole thing right now.
Yeah.
The trade policy for years had ignored the distribution effects, and now we have all these political outcomes. because
And
of it.
we could end up, at this point, I don't know, it could be it's what John Wally would call a pitfalls paper. You could imagine that this makes a big difference, and then you run the model, you discover it doesn't matter for some reason. So I don't know exactly what I'll learn. I love this about this thing, is I form a question in my mind, I don't know the answer. I turn to the model and ask the model to tell me, and then I may be surprised, or I may find that the intuition is consistent. But my guess is it's not very much. It's only in cases where you have a very high carbon price, which means that you have ambition, high climate ambition, low performing technology, high carbon prices. The border measures may have a spillover effect, but my guess is that they're second order.
Mhm.
You might.
That's what I guess, yeah.
Discover their large. That's the paper I think I'd like to write.
No, it's interesting, yeah.